Okay, the basics of Gherkin, writing features, and scenarios are now behind us. Now, how does this behat thing fit in? Imagine we've gone back in time 25 years, and Linus Torvalds, the Yoda of Linux, comes to us and says, I would love your help in building the ls command. Yep, the ls command right here in the terminal. Since you're an awesome dev, you reply, I would be happy to help you, Linus, and I'll use Gherkin to describe the feature and the scenarios for the ls command. I'm really into behavior-driven development. Create a new ls.feature file. I'll save some time by copying the feature description in since we've already covered that pretty well. On to the scenario. The first scenario might be, scenario, list two files in a directory. And now we'll go through our given, when, and then lines. Since we need to list two files, we'll need to create those first. Given there is a file named John, and there is a file named Hammond. The user action would actually be running the ls command. When I run ls. Finally, we'll actually test that the John and Hammond files both appear in the output. Then I should see John in the output, and I should see Hammond in the output. Writing the scenario has two purposes. First, it lets us plan out how our feature should behave, and that's what we've been talking about. Second, we want the scenario to be executed as a test to prove whether or not we have successfully created this behavior. To do that, we'll run vendor/bin/behat in our terminal and point it at features/ls.feature. And let's see what happens. So it says our scenario was undefined and something about our feature context having missing steps. And it even gives us some PHP code. Copy these three functions, open up the feature context class that we generated, and paste them there. So what does behat really do? Simply, it reads each line in our scenario, looks for a matching function inside a feature context, and calls it. In this case, it'll read there is a file named John, find that it matches this annotation here, and then execute its function. What's really cool is that because we surrounded John with quotes, it recognized that as a wildcard. In the annotation, we have :arg1, which means it matches anything surrounded in quotes or a number. Our job is just to make these functions do what they say they will do. I'll change this to :filename and update the argument to $filename, just because that's more descriptive. In this function, how do we create a file? How about we use touch filename? For irun, update the arg1s to command. There are a lot of ways to run commands, but we'll use shell_exec command. Lastly, in I should see in the output, update the arg1 to string. And now we're stuck. We don't have the return value from shell_exec above. Good news, there's a really nice trick for this. Whenever you need to share data between functions and feature context, you'll create a new private property. At the top of the class, let's create a private output property and update the irun function to this arrow output equals shell_exec command. behat doesn't care about the new property. This is just us being good object-oriented programmers and sharing things inside a class. This works because every scenario gets its own feature context object. When we have more scenarios later, behat will instantiate a fresh feature context object before calling each one. So we can set any private properties that we want on top, and only just this scenario will have access to it. Now, and I should see in the output, if strpos, this arrow output, comma string, equals false, then we have a problem, and we want this step to fail. How do you fail in behat? By throwing an exception. Throw new /exception and print a really nice message here of did not see %s in the output %s. Finish that line up with string, comma, this arrow output. Okay, let's give this a try. Rerun our last behat command in the terminal, and this time it's green. And if you run the ls command here, you can actually see the John and Hammond files listed. Back to our scenario. Get out some pen and paper. We need to review just a little bit of terminology. Every line in here is called a step, and the function that a step connects to is called a step definition. This is important in helping you understand behat's documentation. Oh, and the 4 lines of the feature at top, those aren't actually parsed by behat. We only write those to go through the exercise of thinking about our business value. Now you see in our test, it says 5 steps, 5 passed, which means that each step could fail. The rule is really simple. If the definition function for a step throws an exception, it's a failure. If there's no exception, it passes. Head back to the step that looks for the Hammond file and add the number 2 to the end of the file name so it fails. Running the scenario in our terminal now shows us 4 steps passed and 1 failed.